and go to part design, save as part 1, choose the XY plane and sketch. Draw a rectangle shape with the height of 80 millimeter and a 40 center line distance with 150 centimeter length, and center it with 75 millimeter and pad it in 20 millimeter. Select the surface and go to sketch. Draw a smaller rectangle inside the surface. Each side it must be equal to 10 centimeters equally. And draw another rectangle shape inside the smaller rectangle with another 10 millimeter equal distance. And then corner it with 10 millimeter radius. And for the second larger rectangle, you corner with 20 millimeter radius. Exit workbench and pat it with 10 millimeter. And then sketch the outer rectangle and draw a circle with each corner of the plane with the length of 10 millimeter sides. And then mirror the circle at the center for 4 parts, 4 corners. Draw a center circle with a 20 millimeter and workbench, and then press pocket with 30 millimeter. Draw a bigger circle with a 35 millimeter diameter. Exit workbench and pocket it 5 millimeter. And then choose the XY plane and sketch. Draw a rectangle with a length of 150 millimeters and the height of 80 millimeters. Centralize it and exit workbench and pad it with 40 millimeter. Okay, the next part is assembly. Go to mechanical design and press assembly design. Go to component, existing component, and choose the part 1 and the stock one. Go to properties, then choose the color and choose the transparency. Put it in an optimum level so that you can see the stock and the part. Press apply and OK. Move the stock part above and offset the bottom part of the stock and also the bottom part of the part. Offset at the value of -5 millimeter. Next, press start. Click on start, select machining and select advanced machining. Choose part operation, double click it and select default reference machining axis. Select the center point and click on the upper left side corner. And press OK, and part operation option will be popping up. First click on stock and hide it. Click on the design part for simulation. And click on the top part of part 1. Click on stock and unhide it and click on the stock and click upper part of the part 1 of the stock. Click on the safety plane and hit on the upper part of the stock. And click OK. Click on the machining process to check out the default reference machining axis for part operation. and click on the manufacturing program and hit on the roughing mechanism. Click on the rough stock and click on the upper part of the stock. Click on the safety plane and also hit on the upper part of the stock. Click on bottom, go to the other side of the part and click at the bottom part of the part. Click on the part, unhide the stock, and hit on the upper part of the part 1. Check it out properly and move out to the first layer, the tool part style, select zigzag, change the machining tolerance to 0.001 centimeter. Select axial and change the maximum cut depth to 0.05 centimeter. Go to the third option, Untick the ball and tool. And press more. Make sure to select the right diameter for each of the part. For the nominal diameter, select 0.5 cm. For the corner radius, put it as 0 cm. Overall length, change to 10 cm. The contact length, change to 5 cm. The length, change to 5 cm. Also, the body diameter, change to 0.5 cm. And the non-contact diameter D and C is 0. Go to technology, change number of fluids to 2. Check the other options. The way of rotation may be right. Machine quality may be either. Composition one piece. Tooth material high speed steel. Leave it blank for tooth distribution and tooth material desk. 0 degrees for both axial to rig angle and radial to rig angle. Go to feeds and seats. Check all of the options and make sure it's all 0 till the max machining feed rate, which is you have to put with the input of 1000000 mm_mn. Go to the fourth option. Untick the automatic compute from tool feeds. Put the machining into 10. Don't change the units, just write it 10. And untick the automatic compute from tooling feed and speeds, which is the spindle feed. Go to the final options. Change the mode to helix. Go through pre-motion. Select with the A with the arrow above and change the value of 1 centimeter into 0.1 centimeter. Make sure you choose the thin line. It is 0.1 centimeter, so don't get confused. Go to post motion and do the same thing. Change the 1 centimeter to 0.1 centimeter. This is to give the cutting edge. And just give a good observation and press OK, preview, and press OK for the roughing parameters. Press preview again and press OK for double confirmation and select the tool part, and here you go, the roughing animation is here. and make sure the green highlight part is just on the upper layer. If it's in the low layer, it will cut fully, so make sure it's only in the upper layer, and move the toolpath to check it out. Make sure it's in the correct angle so that you can record in a good position, and you can increase the speed by moving the spindle and press the recording icon and press the forward replay button, and here you go. This is a zigzag cutting. You can change the angle to have a good view. Make sure it cuts beautifully to have a great design look, and make sure there was all the hole that needed to be, and that's it. That's the machining process, and I will give you a 360-degree views. And that's all. Press OK, and we will go to the next part, which is NC coding. Make sure to save this. Okay, time for NC code process. Go to tools, options, and press machining. Click output. For the post processor and controller emulator, press init, and the extension is NC. Press OK. Let it load. Right click on manufacturing program, go to manufacturing program object, and generate NC output interactively. Make sure it's NC code, and the one file is for all selected program. Make sure you save it in the desktop. Go to NC code, Synit post processor, select CNumeric 840D 3x.pp. Go to formatting, make sure it's in this setting, and also tool motion. Press input, output, and execute it. Press OK, and the NC code will be displayed in the saved location, which is, in my view, is the desktop. So here it is, process zigzag, and here's the NC code. So that's it, simple as that. And now is for the concentric process. You can use the same zigzag process layout, you can save it differently. So you choose on the part operation, go to the roughing, double click it, double click roughing, and you must redo again the roughing one process. Click on the first option, go to the machining, select the toolpath style. Nope, let me refresh again, double click on the roughing, click on the part operation, and make sure to check the prod body, the stock, and the safety plane is in the correct order. Make sure all in the correct order, and also the default referring machining also in the right order as in the previous zigzag process. So double click on the roughing, press the rough stock and hit on the upper part of the stock. Click on the safety plane and hit on the upper part of the stock as well. select on the bottom part and hit on the bottom part of the stock. Let me adjust it and turn it around. Click on the upper side of the part, so you have to hide the stock and you have to click on the upper part of part 1, and there you go, same as the previous version. Go on to the first option and change the tool part style, this time to concentric. Previously was zigzag, this time was concentric. And check the machining tolerance, make sure it's 0.01 centimeter. Go to axial and make sure the maximum cut depth is 0.05 centimeter. Go to the third option, do it exactly the same as the previous part. Untick the ball end tool and press more. Check on the nominal diameter, corner radius, overall length, cutting length, body diameter and non-cutting diameter. So we have to do a few adjustments here on the length. Alter the nominal diameter to 0.5 centimeter. The corner radius, make it 0. The overall length is the overall length is 10 centimeter. The cutting length is 5 centimeter. The length is 5 centimeter and the body diameter is 0.5 centimeter and the non-cutting diameter DNC is 0 centimeter. Make sure you get it right so that it will not cause any trouble during the cutting process. Press the technology options, change the number of fluid to 2, the wheel rotation right, the machining quality either combustion 1 piece, tool material high speed steel, leave it blank for tool description and tool material description. Actual tool rake angle and radial tool rake angle is 0 degrees, and check on the feet and speeds and go on to the fourth option. Untick the automatic compute from tooling feeds and speeds. Untick the automatic compute for tool feed and speeds for both feed rate and spindle speed. Change the machining to 10 mm_mn. And click on the fifth option. This time you can't alter the mode because concentrates provide helic mode only. So make sure all the readings are good and go to the pre-motions, select the A arrow and change the 1 centimeter to 0.1 centimeter. Press the preview button and press OK. And click on the toolpath computation, let it load, and as again make sure the upper part is highlighted green so that it will not affect the cutting edge, and press the recorder, adjust to a good viewing, and press the forward replay, and it will start to cut. This will take a bit longer than the zigzag cutting tool, so you gotta be patient. And here you can start looking at the holes being created. And we are almost there, just for the last hole. And that's all. That's it for the tooling mechanism for concentric tool part. And I will give a 360 view. Have a look, all holes are there. And that's it. Press OK, and we will go to the next step. This is for concentric NC code. Click on tools, options, machining, output, init. Make sure the extension is NC. Press OK. Right click on manufacturing program, select manufacturing program object, generate NC output interactively, save it in the desktop, and go to NC code. The Senate per must be numeric 840D3XVP, tool motion same setting, formatting same setting, input and executed. Make sure the NC code and for all selected programs. Execute it, and it's loading. And press OK. Go to the desktop to search for the NC code. And where it is. And yes, here it is. Process for concentric, and here's the NC code for centric process tool. That's all. Thank you very much.